Okay, primary trig ratios are like it's not an introduction to trigonometry, but in high school it's when trigonometry starts to really seem a little bit different. Okay, SOHCAHTOA are acronyms to help you remember some ratio relationships in right angle triangles. So for instance, I have a single right angle triangle here. Okay, and it must be a right angle triangle to use these relationships. So that's the first key. Just like your Pythagorean theorem, this one only works with right angle triangles. What we do want to do is we want to refer to specific angles. So there's the other non-right angle triangle here. At this point, we start using Greek letters. Not to confuse the students, though it does become very confusing. Sometimes they'll use theta to represent an angle. It could be anything. You could use happy face, and that's fine with it, right? And then
Alpha.
beta or alpha. You want to do alpha? Sure, let's do alpha. Sometimes written like that is another angle, okay? They're just different symbols to represent variables, that's all, okay? And they usually represent, when you start using the Greek alphabet, angles in a triangle. When we name triangles, though, it's actually common, or another way of doing it is instead of using the Greek letters, I'm going to redraw this same triangle. What we do is we give letters to sides, and then the opposite angle of that side is named the uppercase version of that. So what do I mean by that? So for instance, if I call this triangle C, A, and B, which is very common when we're doing Pythagorean's theorem, that means this 90-degree angle is C, and that's supposed to be uppercase, that's supposed to be lowercase. This is B, which means this angle here, and I'll give it some color. We'll do blue. This angle here would be angle B, and we'd write it as an uppercase. And if this is side A, then this opposite angle would be known as angle A. Okay, so whether we use the Greek letters or we just use the uppercase values of sides with lowercase names, both are good ways of trying to name a triangle. But how does SOHCAHTOA come into this? Depending on the angle we're trying to find, or the side, we use different ratios. So there are 3 ratios, and we're going to write them out. And the first one, S, stands for the idea of sine. Okay, and now it's very common to use theta in this case. Okay, so we could say it's also B, but I'm going to say sine theta, just because it's probably going to be introduced this way, is equal to the opposite side of a triangle divided by the hypotenuse. Okay, the next ratio, CAH, C-A-H, stands for the function cos. We can reply to the exact same angle, theta, is equal to the adjacent side. Oh my gosh, why can't I spell adjacent? Adjacent. There you go. Divided by the hypotenuse. And then TOA stands for the function named TOA, or tan theta, is equal to the opposite over the adjacent. And the question is, what do we mean by these? Okay. How do we set this up? Well, I'm going to redraw this triangle here, and then we're going to set these ratios up. Using these functions, and we're going to use them, they're from a calculator. We're not going to do them by hand. Let's call theta, okay, which we had in our other triangle, we called that actually angle B. Okay, so this is angle B here. So if we're going to set up this ratio, we're looking for the opposite side. Well, the opposite of angle B is this side down here, and it happened to be side B. Okay, hypotenuse, we already knew from before. It's always the longest side of that right angle triangle. So we set it up like that. That will be that side. So in other words, there's a ratio that states sine of some angle B is equal to side B divided by side C. And then we're going to actually put values in to figure this out after. Okay. If I was doing that same angle, angle B, I might say cos B is equal to, well, adjacent. For B, the adjacent side is actually this side here, which happened to be side A. Okay. So in other words, that's over side A over the hypotenuse, which is side C. And then tangent of theta, the exact same angle, we'll call it B. Tan B is the opposite. Well, what is opposite of this angle? Side B, and the adjacent is A. So it'd be B over A. So right now we don't have any numbers at the moment, so this looks a little convoluted. It's just a bunch of letters. Well, we're going to set up, I'm going to set up a different triangle. I'm going to set up your other one there. So we have a little triangle here we have from a question. And it turns out we had side, we'll call it this side here, was 6 centimeters. And the opposite of that 6 was 50 degrees. Okay, here we go. I got this triangle, and my goal here is to find, we'll say this side to start. I need to find this side. So what I do is I look at the angle I have. I have angle 50 degrees, and then what information do I have and what information do I need? Well, I have this side of the triangle. Is that the hypotenuse, the adjacent, or the opposite side? What do you think 6 centimeters is in relation to 50 degrees? So opposite side. So when I think of my ratios, I go take a look at the two of them right now. Cos is out of the question. There's nothing opposite in it, so I definitely wouldn't use this ratio. It could be sine or it could be tangent. They both have an opposite side, okay? So I have that set up, and then I need to find x. Is x the hypotenuse or the adjacent side? Yeah, it's the adjacent side. So when I go back up, I'm looking for an opposite and an adjacent. Well, that's not sine. I'm using the tan ratio here. So what I've just figured out is I need to set up tan, my angle, which happens to be 50 degrees, tan 50 degrees is equal to the opposite, which is 6, over the adjacent, which is the unknown. So I've just set up this special ratio. That's one of the hardest parts of this. Then the next piece is just carrying this out, trying to figure out what the answer is to this. I'll quickly show you how to algebraically manipulate this. Think of this like tan over 1. I can do some cross multiplication to get my x over here. So it'd be x times tan 50 is equal to 6. And then I have to get x by itself. So in other words, I divide both sides by tan 50, right? And you're sitting there going, what is tan 50? What the heck does that mean? Yeah, that's what we have. Button on the calculator is going to help us find that relationship. So it is some number. I write it as tan 50 because it's kind of like, probably it's going to be like pi or the root of 2. It's this irrational number that's going to go on forever, right?
Does it have like a specific number like pi?
It will be, yeah. Tan 50, tan 49, tan 50.5. Each of them is slightly different. So what I can do here is I have, let me see, no, it's programming information. Let's jump into Desmos here. Desmos scientific calculator. Awesome. We got, here it is, if you remember, we had 6 divided by tan 50. There's our answer. The answer is 5, but let's do something more. What is tan 50? There you go. That's the value of tan 50. If it was a different angle, 49, slightly different. If it is 80, the number is different. So see how these numbers constantly change.
Does tan have like its own?
It has tan is like almost like an equation in itself that we don't carry out because it's too complicated. We use the calculator to do it. So instead of memorizing this, which is impossible, back in the day you would reference a chart that would have all these numbers. Our calculators kind of have the answers for each tan 1, 2, 3, all the way up through a circle technically, what each of those ratios are. So we've just figured out above it's 5.03. I'm going to just jump right into it. Oh, have some programming there. There we go. X is equal to, in this case, our answer, X was equal to 5.03. So if we go back over and we take a look, this side here is 5.03. Okay, that works out. Yeah, and then I could use Pythagorean's theorem, but I'm going to try another ratio. I want to find this side. And now I have both of these sides. So I can technically use 2 different ratios. I can use sine of 50 degrees, because SOH is opposite over hypotenuse. So what's my opposite? That is 6. My hypotenuse, we're just going to call it y, just so it's a different variable than what we used before. Y. Or cos of 50, we're using that exact same angle. I can set both of them up, I'll get the exact same answer, is the adjacent over the hypotenuse. Well, the adjacent is that other angle I found. Oh, okay, I'm almost done. 5.03 over y. So we now have two ratios we've set up. I'm going to move one of them. And we're going to use our calculator same way. Now, I'll do this part quickly because we've shown it already. Think of it like we're cross multiplying. Okay? And when we do this, what ends up going to happen is this will be y is equal to, I'll just close that, 6 over sine 50. And in the other relationship, it'll be y is equal to 5.03 over cos 50. So we're going to jump back into our calculators to solve both of these, okay? So one of them was 6 over it, and the other was 5.3 over it. And we have sine and cos. Let's see if I can memorize that as I jump to my calculator here. Okay, so our first one, we had 6 divided by sine 50, 7.83, blah, 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 blah. And now we did do a little rounding here, but let's see how well we rounded over cos 50, and our answers almost up to the second decimal are the same. Because I did a little rounding, I'm slightly off, but let's say it was just the first number and the 10th digit, those numbers are the same. So it didn't matter which ratio we set up, we got the right answer there. So we got 7.82. So the answer is approximately 7.82. 7.82. So in other words, this hypotenuse is 7.882. And I could have used Pythagorean's theorem and I would have got pretty much the exact same answer there. But what's important here is Pythagorean's theorem, when we first started this question, I couldn't solve it because I only had one side. Because I had an angle and a side, I could use any of these ratios. I had to figure out which ratio I could use to set it up.
7.28.
Oh, you're right. I wrote it a little backwards. Thank you. 7.28. I think I started that and then I wrote it the other way after.
Yeah.
There we go. Okay. So what's key here is if I have an internal angle and at least one side, so one angle, one side, and it's a 90-degree triangle, I can use these three ratios to find other parts of the triangle. They're very powerful to help us do that. Okay. So